What is the membrane made of?
Composed of.
Thick this marker is. They're never like that.
Awesome. It's just like cellular material, but inside of the membrane are proteins, I guess. I'm not really sure if I understand the question very well.
Oh, that's fine. Let me see. So the membrane specifically.
It's a plasma membrane.
Plasma membrane.
Okay.
And what kind of molecules make that up? Do you remember?
I don't.
Phospholipids.
Phospholipids, okay.
So the way they typically draw it, like most teachers, they just kind of say there's a head and it's got two tails coming down.
Okay, yeah, the hydrophilic and the hydrophobic.
Yes. So what does that mean? Hydrophilic and hydrophobic, what does that mean about the phospholipids?
That they're water or that they're going to pass through easier than water soluble molecules.
What can pass through easier?
The phospholipid itself.
No, well because these stay here, these are the membrane, so they're not going to really pass through, right?
Okay.
So the whole cell has a membrane that is made, it looks like this all the way around. The phospholipids.
Okay.
The heads on the phospholipids, they're attracted to water.
They're the hydrophilic. Yes.
They're hydrophilic, yes. That's because the phosphate group on top is polar, and water is polar, so they attract. Now the tails on the inside are what? Phobic. And that's because the tails are nonpolar. So they don't attract to water, they don't like water, they repel. So that's why if you're in a fluid, there's a bunch of water, the cell's membrane orients itself like this. The heads are on the outside and inside because the cell has water on the inside and the outside, but in between there's no water.
Okay.
Is it kind of that, and that's why the tails orient themselves like this, to kind of hide from the water.
Okay.
So that's what the membrane, that's what the phospholipids are.
Yeah, and that looks like the pictures that I've seen in the book.
Good.
Sometimes I just don't remember ever reading that. And it's like,
yeah, it's hard to get it stuck sometimes.
Well, now it should be stuck now. So.
Good. So why they call it the fluid mosaic model? Fluid because these two sides of the membrane, they can move like this. They rotate, they can shift. This one can go this way, this one can go this way. It's just not, just don't think of it as a solid structure that's hard and doesn't move.
So
it's
very flexibility.
It has flexibility, it's fluid like water, it moves. This guy can trade places with him. You know, they can they can all switch around.
Okay. As long as but the ends never switch. Like the tails are always lined up with the other tails.
Yes.
And the heads are always facing outward.
Tails are always pointing in, heads are always pointing out.
Okay.
Every once in a while, it's very rare, but these two can switch. The top and the bottom can switch.
Really?
Yeah, there's enzymes. One's called flipase and one's called flopase, and that's what they do.
They flip flop.
Yeah, so one of them does one direction, one of them does the other direction. You don't necessarily need to worry about that, but just know that they can occasionally.
So phospholipids make up the membrane.
Make up the membrane, very fluid, change positions.
Okay.
Now mosaic is because, or have you ever seen like a mosaic, mosaic painting or whatever?
Art and stuff.
Like it's just like a bunch of kind of little things. The membrane, if you look down on it, say we're looking down on a cell, on the top, and there's all the phospholipids all around right here. There's a bunch of proteins in it too, scattered around. And that's why it's called mosaic, because these proteins are in there, in between the phospholipids, and they move around too. So you can say like for example, say this is a protein kind of sticking up right here. This protein could go over here, could go over here. The whole thing's just kind of moving and fluid.
Okay.
All right?